Hello students, I hope all of you will be good. In the previous lecture, I have made a video on one sample t-test. So in that video, I have performed a test on Minitab as well as in SPSS. So today I'm going to perform an extension of one sample t-test. We will do two sample t-test using Minitab and SPSS. So why we use a t-test in order to perform a t-test? Oh, the condition is this, that the sample size should be less than or equal to 30, and if the sample size is greater than 30, then we'll use a z-test. Okay. And the second condition is that we do not know about any idea, and we don't have any idea about the sample, about the population standard deviation. Okay. So these were the two conditions. Now we will move towards the data. I'm solving the problem of Design of Experiment book by Douglas Montgomery. So I'm solving the problem number 2.29. A photoresist is a light sensitive material that has been applied to the semiconductor wafers so that the circuit pattern can be imaged onto the wafer. After application, the coated wafers are then baked. They are baked on two different temperatures on 95 degrees centigrade and 100 degrees centigrade to remove the solvent in the photoresist mixture and to harden the resist. Here are the measurements of photoresist thickness in kiloampere for 8 wafers. So 8 wafer is our sample size, n is equal to 8, and these 8 wafers are baked at two different temperatures. Assumption is that all of the runs were made in the random order. So why we use runs in the random order? In order to remove any chances of biasness. Further, n is equal to 8, so it means that it qualifies the condition of t-test that the sample size is less than 30. Further, if I explain that in this test we have to compare that whether there is any difference between 95 degrees centigrade, the process that has been performed on 95 degrees centigrade, and the same process that has been performed on the 100 degrees centigrade. These are the two different settings, and we want to compare that whether these two operating conditions that have same effect or they have different effect. I hope by reading this question statement and what I have told you people, now you can understand the problem, what the problem is. So then, okay, from this statement, okay, so here are the measurement two different temperature of these. From this we can get the idea of that we're comparing the process. These are the 8 different observations on both 95 degrees centigrade and 100 degrees centigrade. I have input a data in the Minitab. This is the data at 95 degrees centigrade at 100 degrees centigrade. Now, in order to perform the t-test, we will go to stat, we will go to basic statistics, then basic statistics, we will select once two sample t-test. Here the two sample t-test, we got few options that both sample are in one column. No, they are both samples are in separate columns. So we will pop up, and in the drag down column we will select each sample in its own column. Okay, that's good. So sample 1 is in column C1 at 95 degrees centigrade. Column sample 2 is at in the column C2 100 degrees centigrade. We will go towards the option. So in order to perform the in order to select what are the options are available, we will, it's at alpha value 95 degrees centigrade. It's about its hypothesis. Again we will go towards our question statement. So the question is there any evidence to support the claim that higher baking temperature, that is 100 degrees centigrade, it will result in a wafer with a lower mean photoresist thickness, that the product that is we are getting have at 100 degrees centigrade will have a lower thickness. Here is this data, okay, and the product that we are getting at 95 degrees centigrade that has a higher thickness. So we'll have to compare it. You can obviously see in the question that it is here the measurements of photoresist thickness. Okay, so this is of important thing, photoresist thickness. Okay? We are going to compare that whether there is a difference between 95 degrees centigrade and 100 degrees centigrade. So then at 100 degrees centigrade, as per the statement of the question, that this thickness of the sample we obtain at 100 degrees centigrade will have a less thickness as compared to at 95 degrees centigrade. So based upon this, we are going to hypothesize over hypothesis. Okay, so that difference among difference between is less than hypothesized mean. We are going to select this one. So we have three options that hypothesized difference is greater than the difference. So what's the difference? Difference is the if we are going to subtract the sample mean of first sample minus sample 2 mean. So there are two samples, we will take mean of them and then we'll subtract, we got this difference. So difference is that, and hypothesized difference is that we are going that whether as per the statement that the sample that has been treated on 100 degrees centigrade is has less thickness as compared to sample that has been treated on 95 degrees centigrade. So as per the statement, I'm going to again repeat my statement that as per the question statement, our thickness of the sample 2 mean will be less than thickness of the sample 1 mean. It means that this value will be smaller than as compared to sample 1 mean. So our answer as per the hypothesis will be always in the always positive. It will be, so the difference will be greater than the hypothesized mean. We will select this third option here. We are going to assume equal variances, hit click OK, and then we will perform over, we will hit click and OK. This is the result we have obtained on the Minitab, and we got this that these are the two samples. We got the mean, standard deviation, and the difference among two is 2.52. Good standard deviation is 1.84. Okay, so the t-value test satisfied 2.68, and we got p-value 0.009. That is too much less than our alpha value. Alpha value we have taken 95%, or alpha is equal to 5%. So it means that based upon this p-value, we are going to take the decision that we reject our null hypothesis that the mean difference among there is a significant mean difference exists among the two among the mean value of the two samples. Further, we have taken that in the alternative hypothesis we have made that the mean sample of the sample one, mean of the sample 1 minus mean of the sample 1 should be greater than 0. So we found this one correct. Okay, so we'll say that we reject our null hypothesis, okay, in favor of alternative hypothesis, because our p-value is too much less than 0.05. Technically, we will say that it is found to be true that the thickness of the sample 2 that is smaller than thickness of the sample 1. So this is all about this lab in the I've solved in the Minitab. Now, if we talk about the same problem in SPSS, first of all, we will go to data. Two things I have a temperature, and I have you can see a thickness. Okay, I've read both of them. There are I have two values of you can say one of them is 95 of temperature, and we will label it as 1. Then I have value of 100. I will label it as 2. I will add both of them, then hit click OK. So then we will go to data view. We have temperature, we have thickness. So I will just copy and paste the data. So you can do it like this. In this, I've done this. Okay, you as have 8 values for one here represents 95 degrees centigrade, and 2 represents 100 degrees centigrade. So I have written the values in front of both 1 and 2. Then I'm going to analyze both of these values. Go to analyze, compare means, independent sample t-test. So here we got, okay, over what we can change in this you can say experiment, we can change over temperature. So temperature is independent. Always we keep the independent variable as a grouping variable. Okay, then we will keep thickness as an independent variable. Okay, as a dependent variable, because the thickness, it depends upon the temperature. So we will always keep the dependent variable as a test variable. When we will put here, you can see if I go back, when I put the temperature here in a grouping variable, two question mark arises that what are your groups. So I will have to define the group. that I have one group, one represents 95 degrees centigrade, two represent 100 degrees centigrade. Click hit and OK. Then click OK. You will get a result sheet. Okay. So my result sheet is this one. Okay, I got the result sheet. In this result sheet, it is going to tell us that our two groups both have 8 sample size. This is the mean value of the both 95 degrees centigrade and 100 degrees centigrade values. Okay, then standard deviation is 2.099. That's 1.64. When I came towards, you can say, towards analysis. So we get t-test statistics 2.675, and I've assumed that equal variances, for equal variances, its degree of freedom is 14. Two degree of freedom have been lost because of two sample t-tests. So I've calculate the sample size is 8 plus 8, and because I've calculated the mean value, so we lose 1 degree of freedom for each of the sample. We got significance of 0.01. Okay, so this is all about both of the test. In Minitab, we got in the both of the test, we have rejected over a null hypothesis, and we have found that there is significant difference found between 95 degrees centigrade and 100 degrees centigrade. Two things we will a little bit confused at here is in the Minitab, we got the value that is too much less as compared to the value we got in SPSS, because in the Minitab we have formed one tail t-test, whether however in the however, in SPSS, we perform two-tailed t-test. So this is the all of what is the difference in between the p-values of the both of the tests. Thanks a lot for watching this video, and if you have liked this video, please hit hit the like. Okay, and if you want me to solve any other example, please let me know. I will solve it for you both on Minitab, SPSS, and you can say also on the Excel. Thanks a lot for this watching this video.